Now we already saw a graph for liquefaction of CO2 at different temperature, and that was same Andrews isothermal. Now here I have not given any temperature. So let's quickly revise what we did just now. We know here certain temperatures are given and they say T4 is greater than T3 Tc. So if it is for carbon dioxide, this is going to be 50 degrees and T3 can be any temperature below 50 but above critical temperature. The critical temperature was 30.98. So this will be somewhere between this. So I can call it 35.5. At 50 it is behaving like ideal gas. At 35.5 it's deviating from ideal gas. And Tc is 30.98 when the Pc is 73. At point C, the CO2 is getting converted to liquid. This side is liquid, this side is gas. It's very clear from the graph. Okay. Now, anything below the dome, if you see there is a dome, this side will be liquid and this side will be gas. Okay. So there is an equilibrium. And what do we observe? Once we go below Tc, the temperature here is 21.5 and T1 is 13.1. So at 21.5, what is the pressure going to be? Now here we said it's 73, correct? So here it's 60 and here it's 50. Okay, you should have an idea that at critical it's becoming liquid. Below critical there is equilibrium. To the left side liquids, to the right side gases. This is Andrews isothermal for CO2. Okay. You have to by heart all these things. Tc is 30.98. Clear? Now this is again the same graph, but this is given in your NCERT. So check again 50 degrees, 31.1, that is 30.98 critical temperature. This is 21.5, this is 13.1. This here it's 50, 60 and 73. This side it's gas. To the left side of the sea it's liquid. Below the dome shape it's both liquid and gas. Am I clear till here?